Okay, here's our chapter on friction. This is section 5.4. We skipped section 5.3. I don't think Hooke's law is that important for us to do right now, so we may come back to it later, but this is chapter 5.4. Objectives for this: to calculate frictional forces from equation models for static, kinetic, and rolling friction. Solve one-dimensional free force problems that include friction. A box with a mass of 10 kilograms is at rest on the floor. The coefficient of static friction between the box and the floor is 0.30. Estimate the force required to start sliding the box. A 500-gram puck is sliding at 20 meters per second across a level surface. The coefficient of kinetic friction between the puck and the surface is 0.20. Draw a free body diagram for the puck and to calculate the magnitude of the force. How long will it take for the puck to skid to stop? Here are all your physics terms for this part. We will talk about all these in depth. And here are your equations for this chapter. All these look kind of confusing, but there's just, oops, I don't have my pen selected. There's just kinetic, static, and rolling, and we're not going to do rolling. We're just going to do kinetic and static. These are the only two you have to worry about, and if you look at it, they kind of are the same thing. What is friction? Friction is a catch-all term that collectively refers to all forces which act on or reduce the motion between objects in the matter they are in contact with. Friction often transforms the energy of motion into thermal energy or the wearing away of moving surfaces. So if you're traveling this way, friction is going to go that way. Friction always goes the opposite direction. So you have air friction here with motion going this way and friction going the other. Rolling friction, which is basically like your car rolls and then friction goes the opposite direction of the way you roll. Sliding friction, which is what we're going to talk mostly about. And then you have viscous friction, where things that are fluid and how the fluid things move. Kinetic friction is sliding friction. It is a force that resists sliding or skidding motion between two surfaces. So if the motion goes this way, friction goes that way. Motion's going this way, friction goes that way. Are you catching what's happening here? Whatever the way motion goes, friction goes the other way. It is everywhere. We can't get away from it. It's the nemesis of all physics problems. If a crate is dragged to the right, friction goes left. All right, a board. Which takes more force to push or pull on a rough surface? Pushing it or pulling it? So you have a board sitting here, or a board with 3 bricks on it. Well, the board of bricks, of course, because you're putting more mass on there. If this weight triples, then the normal force also triples, and that force of friction applies too. And we haven't talked about normal force. We will in class. Normal force is basically the force that pushes down. Well, weight pushes down, and the normal force pushes up, and it's the exact opposite. So your weight goes down. Oh, that you can't read that at all. And the normal force, which is that, goes up. They cancel each other out. All right, a model for kinetic friction. The force of friction, that's what this is, equals the coefficient of kinetic friction times the normal force. So this is also, you can find with the weight of the object. But what is the mu k, the coefficient of friction? Basically, there's all kinds of coefficients out there. There's coefficient of static friction, coefficient of kinetic friction. Basically, what people have done is they figured out how the coefficient of how things move across one another. The coefficient of friction is a constant that depends on both materials. Pairs of materials with more friction have a higher UK, coefficient of friction. The UK tells you how many newtons of friction you get per newton of normal force. Do you see why this has no units? This is a force which is in newtons, this is a force which is in newtons, and they cancel as you divide them. The coefficient of friction is typically between 0 and 1. It's a very, very small number. It's usually a decimal place. When mu k is 0, there is no friction, which is very hard to do. When mu k is 0.5, the frictional force equals half the normal force. When it is 1, the frictional force equals the normal force. Calculating kinetic friction, consider a 30 Newton block sliding across the floor at constant speed. What force acts on the block? Draw a free body diagram. Let's do that. Well, if you look at that, this mg, that's the weight that's going down. This Fn, that's the normal force that's going up. The force, the applied force, is going this way, and the frictional force, which is the coefficient of friction times the normal force, is right there. So these are all the forces, all 4 forces acting on it. These two are kind of canceling each other out. So you have the applied force has to be stronger than the frictional force for it to move. So we have 0.5 times 30 equals 15 newtons. The force F needs to make the board slide at a constant 15 newtons. Static friction is gripping friction. It is the force that prevents relative motion between the two surfaces. So whenever you pull on something and it doesn't move, that means you haven't overcome the static friction force on that object yet. Without static friction between your feet and the floor, you could not walk or run. You would basically just slide and slip off because you have no traction. Without static friction between your tires in the road, you could not start or stop because you would just keep going. You need that friction. Static friction prevents this crate from sliding when pushed. He's pushing with 120 newtons. The mass is 40 newtons, but he's not going anywhere because if you go 40 times gravity, which let's say is 10, so it's 400 newtons, that's too much. He's not pushing with enough. So, not until pushing the force is greater than the maximum static friction force could you actually push it. We're missing the slide. I don't know what happened. We'll talk more in class. Sad. Oh, here's the bottom of that other slide that we just had. Still sad. My slides are not coming up. Here's this again. How much static friction acts on this? In case A, we said it was 120 newtons, and this is 160 newtons, and this is going to be apparently 200 newtons, and it's probably going to mess up on us still. Nope. So static friction is going to be F max. This is basically the maximum amount of static friction before it starts to move. Now we have mu S instead of mu K, and it's the same normal force. A 10 Newton board is rest on a table. How much force does it take to start the board sliding if mu S is equal to 0.2? So let's look at it. And these are messing up. I'm going to have to get a new program that does this, that brings my PowerPoints in so I can record over this. We'll talk more about this in class when we meet next. Yeah. Remind me in class, we're going to talk about this. Here's a list of some common mu S and mu Ks. So for each board it has different mu's, and how you can use these mu's to figure out how much force you need to get something to start moving and then to keep moving. Like I said, we'll talk more about this in class. And these coefficients of friction are only estimates, subject to plus or minus 30% or more uncertainty. That's a lot of uncertainty. A lot of uncertainty. There are other books out there that have better. Actual experiments are needed in any situation where an accurate value is required. Evaluating models. The scientific explanation of models for static and kinetic friction use constant value for each frictional coefficient. Analyze these models for friction by using the percent variation in your results among trials. Critique these models based on your experiment training. And evaluate the models by comparing your experimental results to the tabulated results of the coefficients. How precise are your models? This is one way you could go about figuring out if your coefficients that you're using from a table are working correctly. Basically, you have friction on the block on the table in a stand, and you put a mass in a cup in this height, and when you put more masses in as this travels down, you can see how far this moves, and you can figure out your coefficients that way. Alright, viscous friction. This is one of the ones I wanted to talk about. Fluid friction is the largest source of friction for cars, boats, and aircraft at speeds 50 miles per hour. There are two main sources of friction. The force required to push the fluid out of the way, and the resistance of the fluid due to viscosity. Viscous friction is complex. It depends on speed, shape, and fluid problems. We will not do any math involved with viscous. I just wanted to teach you about it. Viscosity describes a fluid's resistance to flow. Air has a very low viscosity. Water has a low viscosity and pours readily. Honey has a high viscosity and pours slowly. So I'm hoping you understand how viscosity works. Okay, here's your assessment. A box with a mass of 10 kilograms at rest is on the floor. The coefficient of static friction between the box and the floor is 30.30. Estimate the force required to start the box moving. So the force of friction is equal to the mu S times the normal force. So 0.3 times 10 kilograms times 9.8 gave me 29.4. So that's the amount of force you would need to get it to start moving. 500-gram puck is sliding at 20 meters per second across a level surface. The coefficient of kinetic friction between the puck and the surface is 0.20. Draw a free body diagram for the puck. Here's your free body diagram. The direction of motion is this way. The frictional force is that way, and the normal force is that way. Oh, and normal force is this way, the frictional force that way. So to do our calculations, to find the normal force, which would be our 500 kilo, we had to change that from grams to kilograms, times 9.8 gave us the weight, or the normal force, of 4.9, and then we could calculate this. So how long will it take? What is the acceleration of the puck? So now we're looking for A. You might hear my dogs barking in the background because I think people are coming home. Well, force, when we talk about Newton's second law, hopefully you've read that in the book. Force is equal to mass times acceleration. I haven't had notes over this yet. But acceleration then would be force divided by mass. So when I find the force, which was the force of friction divided by 0.50, gave me this acceleration. So once I have my acceleration, I can then say VA equals our V divided by T. So I could then say T equals V divided by A, which is what this is, to figure out that it was 10 seconds. And we're going to do these problems in class, and we're going to do several of these. I'm not expecting you to just pick it up from this.